Now coming to the current session, Secure Your API Program with Azure API Management is presented by Toon Vanhoutte. So in this session, he will show the complexity around access control of APIs and their consumers when you have APIs that are using multiple standards and security mechanisms. He will explain today how you can leverage Azure API Management to optimize, streamline, and standardize your overall API security. Toon, it's all yours.
All right, thanks for the introduction, Mohan. So first, before we kick off, a little word about myself. So my name is Toon Vanhoutte. I'm from Belgium. I work as a CTO at Noest. At Noest, we craft custom solutions for making people's life easier and more efficient. We do that with .NET and Blazor. We host our applications in Azure Platform as a Service, and we try to combine them with the Microsoft Power Platform. Also, I'm a founder of Your Azure Coach, where we provide very expertise training sessions with anything that has to do with Azure. And last but not least, been awarded as a Microsoft Azure MVP, mostly in the thanks to my contributions in the area of API management and logic apps. So I had my session prepared already a month up front, but then yesterday I had an idea. Maybe it's a little bit too theoretical. Let's put some more demos in it. So yesterday evening, I changed my session a little bit, but the focus is still the same. It's about securing your API program. So the focus will be mostly on demos. So why not starting with a demo? So in my case, I want to create an HR API where we want to create one operation that gives you back the employee info. So the information of the employee. We will start with a very simple setup where API management is configured with mocking, and we use Postman to call the API management. We don't have any security to start with. So let me go to my API management resource and create a blank API over here. We call it the HR API. We give it a suffix HR API like this, and we create a blank API. In the settings, I will change this setting, so we don't need a subscription key to call the API. So this ensures that the API is open on public internet right now without any security. Of course, this is not the intention, but you get the point. We will improve that later on. So the endpoint, I can call it the get employee info, and we can do a get on the me/employee info endpoint. So it's important here to consider this me. This means we want to return the info of the employee that is logged into the application, into the API. So that's very important. That's why we explicitly put this me over here. Let's save this and let's configure some mocking on this operation. We can do this with a rather simple policy. Here, the return response policy. So we return a response with the status code 200. A content type application JSON, and then a fixed hard-coded JSON body with an email, first name, and so on. And see that the email is from our mocked user. So let's save this. Go to the test pane just to grab the URL. Now I can go here to my Postman, call this API like this, and hopefully this works. Yes, we're good to go. We have an API operation, my get employee info endpoint running in API management with mocking configured. Of course, we need to think about security. So during this session, I will always come back to this overview. Because if you're using API management to secure your API program, you need to always think about securing your front door security. So the communication between your API consumers and your API management. But also don't forget to secure your backdoor, the connectivity between API management and your backend APIs, because it's not the intention that API consumers bypass your API management and go directly to the backend APIs. So if you look at the front door security, there are several options available over there. One of them is network security. So you can deploy Azure API management internal to a virtual network, which means that by default, only API consumers that are hosted in the same virtual network or in any peer network can consume that API management instance. If you want some of these APIs to be exposed explicitly on the internet, you can of course configure that with, for example, an application gateway. Firewall functionality is also needed. If you run a public API program, it is advised to have some firewall capabilities. As it has some native firewall solutions, you can also have your own network appliance, of course, configured. IP restrictions is a very simple measure that was often used in the past. Nowadays, it's a little bit more difficult because many of your API consumers are running on cloud technology, which means actually that they don't have a static IP address in many cases. And rate limiting is also something that you can do if you run an open API program, where you make sure that your API consumers cannot excessively abuse your API, so they are down on their knees. So for this demo, for my scenario, I want to put a firewall in front of it, and I will take Azure Front Door as an example. It's important to note Azure Front Door is a global service, so it's not attached to a single region. It's a global service, and it can be used as a load balancing solution to load balancing between different regions. If you would have an API management in West Europe and North Europe, you can put Azure Front Door in front of it. The current version has no network integration. That means that your endpoints that you want to consume need to be available on public internet. You can integrate Azure Front Door with a WAF, a web application firewall, which protects your APIs against the OWASP top 10. Examples are the SQL injection, cross-site scripting, and these kind of things. You are protected by that. You can customize the rules. You can write your own rules if you want to. Next to that, Azure Front Door is also a content delivery network, and it can improve your performance thanks to caching. And be aware that the routing of the calls between Azure Front Door and your API manager goes over the global Microsoft network, so you have lower latency over there. So in this demo, I want to configure Azure Front Door in front of my API manager. And then I will configure API management to only allow communication from Azure Front Door. I created this already up front because creating a front door can take some time, so I didn't want you to wait. So if you go back to my Azure environment, we have here my Azure Front Door, and here in the Front Door Designer, I created a single front-end host, which is just your host name where you want to connect to. This is the standard one, but of course you can add your custom domain if you want to. And then here you can add your backend pools. We are talking about a pool because Front Door is a load balancing solution, so you can add multiple backends to the same pool. In my case, I only have one backend, which is my API management. I'm only using one region in this case. So you can use native Azure services to connect to, or you can use a custom endpoint. So I configured here my backend. And then for your backend pool, you need to configure the health checks. Azure Front Door will, on a continuous basis, and here in this case, in every 30 seconds, check if my API management instance is still alive. We need to configure that. So we need to provide the health endpoint of API management. This is this strange URI path. We do that through HTTPS, and the probe method should be get. Make sure that you configure this right. Otherwise, Azure Front Door will think that your API management is unhealthy. The next thing we need to do, we have a front end defined or back end pools defined, so we need to define the routing rules between them. And this is what I've done here with my HR API routing rule, where I only allow HTTPS traffic. What I did also is patterns to match. So I only want to allow here the calls that have the /HR API and then a wildcard. So everything on the /HR API can be routed to this backend pool, and this is my API management. You can also redirect URLs if you want to do that. This is like this, and maybe one more thing that I didn't show you, but I enabled Web Application Firewall over here. So the Web Application Firewall, which is a separate resource within Azure, is also linked to this. So what can I do right now? I should be able now to call my API manager through the front door. If I change here my URL from API management to front door, I hope to see still again this mocked endpoint. Yeah, so you see, changing the URL, now I'm going through the Azure front door. But I can still call my API management, and that's not the intention. So we need to protect our API management and make sure that it only allows calls from the Azure front door. We can do that over here in our global API management policy, and we can write a policy like this. We replace the inbound section, and I do something like this. We check on an HTTP header, and Azure front door injects in every backend request a custom HTTP header, which is called the X Azure front door ID. You need to replace that with the unique ID of your Azure front door. So in my case, I can grab it over here and replace it over here. So this security makes sure that only Azure front door can consume this. I agree it's a little bit of cumbersome experience. I know that the product teams are working on a more secure security between the two. I hope it will be a network level security and not like this, because of course, if you know the X Azure front-end door ID, you can of course simulate that. If I now try to call my API manager directly, it will not work. It should work, at least. Did I change anything? Nope. So, let me give it a try again. Yeah, there we are. So I get my mock response again back. It's good to show you that, for example, if I try to do some SQL injection by adding here an OR statement with a statement 1 equals 1, which is always true, I should be blocked. Yeah, I get the 403 forbidden back. This is my WAF demo. I call it the WAF demo. That is blocking my request because it thinks that we are doing and trying to do some SQL injection. So back to the drawing board. We have now already network security configured, but we need to go more. We need to do authentication and authorization. For authentication, that's really enforcing that you know who is calling your APIs. You have several options. You can use an API key in the HTTP header or the query string. I prefer the HTTP header because that's not tracked in server log. If you use API keys, why not using the built-in subscription keys of API management, because it gives you some additional traceability. Basic authentication is more a legacy protocol, but it's the equivalent of an API key in the HTTP header. We also have TLS mutual authentication, which uses client certificates in the TLS handshake, and that's often used when two companies integrate with each other over public internet. In my case, we are dealing with users, so the user needs to be identified, and that's why we use OpenID Connect, which is an extension of OAuth 2 to foresee in authentication. Authorization is then, okay, you know who is accessing your API. With the authorization, you will make sure that you only allow the people or the applications or the customers who are allowed to. And that you can do with, for example, OAuth 2. OAuth 2 is there really to handle the on behalf of scenarios. I am the owner of the data, and I want to give, for example, an application the right to access my private data on behalf of. And this is what we want to do in the demo, of course. I want to give the application the access rights to access my sensitive employee information. Other types of authorizations can be an access control list. I rather compare that with the guest list. If you go to a party, if you're on the guest list, you're in. If you're not on the guest list, you will not be able to enter the party. Groups is just about group membership. Validating is the user or the application part of a certain group. And roles, they give you some claims. You can be an operator, an administrator, or whatever specific role in the context of your API. And based on the role you have, you will get or you won't get access to the API. So if we look at API management and OAuth 2, how does it work? It's important to understand that API management is not an IDP. It's not an identity provider, but it can integrate with any identity provider that supports OAuth 2 and OpenID Connect. In this case, it is Azure AD, but I did also integrations with Auth 0, with custom implementations, and with Okta. The goal is that the resource owner in this case will log into the application, and he or she will be redirected to the authorization service where a login needs to be performed, and hopefully with multi-factor authentication. Depending on the type of application, you will need to choose a different OAuth flow, but in the end, the application will get an ID token and an access token. The ID token should remain in the application, and the access token is sent to the API management, where of course API management needs to validate that access token, that JOT token, JSON Web Token. So that's typically done by the JOT validate policy in API management, and that one is configured with a configuration endpoint. This is the discovery endpoint, the well-known endpoint of OpenID Connect, where API management grasps all the information about the token. What is the issuer? What are the signing keys that are used to validate the signature, so the public signing keys. Once everything is fine, if the token is fine, if it's not expired and these kind of things, you will get access to the API management. You can, of course, add authorization on top of it, and that's what we will do in our demo. We will validate the JOT token of the incoming request, but we also will validate, is a consent given? Is there a consent given by the user that the user consents that the private data can be accessed by the application? So that's what we will do now in API management. We will use Azure AD. So we will need to create an application registration for our API, and we will need to create an application registration for our cloud clients. In this case, this is just Postman. So back to my demo scenario here. So I want to show you the HR API that is already created here in Azure Active Directory. First thing I always do is updating the version, the access token accepted version to 2. This makes sure that you use the latest version of the Azure AD implementation. By default, it's set to null, which means you are using the version 1. Second thing I need to do, I need to expose a scope here. Yeah. A scope that can be consented by our users. So I ask here a scope with the name read employee profile. So I want the end users to consent that one. And here, if I would do this, it's an admins only, then the global administrator within Azure needs to consent. But in this case, I want to make sure that the user consents. And here you can specify what the user will see. Yeah? They want to read, for example, your employee profile, and maybe I can add here integrate behind it, like this. Let's save this. Yeah. So now we have our scope defined over here. The next thing I want to do is show you how this HR client is configured. This one has a little bit more configurations. The first one is again the version 2 over here. The next one is API permission. We want to give this application permission to call our HR API, and we give it access to the read employee profile scope. Important, it's delegated access, which means that the user will need to consent. There's no admin consent required. It is the end user that will decide whether this application can get the personal data, yes or no. The application will also need to authenticate, and typically that's done with the client ID and client secret, which was created already over here. And then we are using the authorization code flow, which means we need to provide a redirect URL, and this is added over here. We have the redirect URL of Postman. So if I now go to Postman, I can configure my API, my application to log in. So I want the user to log in. So you see over here, we are using OAuth 2, authorization code flow, the callback URI, and then the right token endpoints, the client ID, client secret, and the scope. This is important one, the read employee profile scope. So if I now clear my cookies, yes, and I want to ask the user to log in into the application, I will take a brand new user, so I am sure that the consents will not be cached. So this is a new user. Enter the password like this. Even need to confirm the password because it's the first time I log in with this one. And hopefully now I will see the consent screen if everything goes fine. Yeah, and you see this application wants to read my employee profile, and we have the integrate added over here and some more details that I was able to configure on my API. So yes, I accept this. Yeah. Voila, proceed. And we have now an access token over here. You can view and visualize this access token in jot.ms. Then you see what is inside it. It's not too fancy. We see that we use version 2.0. The name of the user is user04. We have also the email address. Normally, this should be in the email claim, but because this is a user without an Office 365 link to it, it is in the preferred username claim. The audience is the client ID of my API, and the AZP claim here is the client ID of my consuming application, in this case, Postman. So now we need to configure API management to validate this token. How can we do this? Well, like mentioned before, we have the validate JOT policy. I can configure this one on the API level, and I can copy paste it over here. So this is a rather big policy. And let me expand it a little bit. So what we do, we provide here the OpenID config URL. So this is an endpoint of Azure AD, where it describes what is already all supported in the OAuth and OpenID context. The most important one is maybe here the Eureka set URI. If you click on this, you can download the public signing keys that are used to verify the token. So API management is downloading this information at initial import, and it's refreshing it on a regular basis. The audience is the client ID of the API. And then we do something additional. We say, if you want to get in, you need to have the scope claim available with the value read employee profile. In this way, we are 100% sure that the token comes from Azure AD and that the user really gave his or her consent. So we've figured it out. Let me now try to call my API management through the Azure front door. I click send, and I get an invalid JOT token back. Let's have a look why it is invalid. I can add here, or I did it already with my subscription key. So I get here a trace location back. And I can have a look at that trace location. And hopefully we will see the reason why. But here it says lifetime validation failed. The token is expired. And yes, this is because I requested the token, but I didn't use it. So I'm still using my old token of my rehearsal this morning. So let me get a new access token. Yes, and explicitly click here on use token. This means I will now use a new brand fresh token. And now I get an ACP 200 back again with my mocked user. This is pretty nice. We have all of this configured right now. What we also need to do in many cases is we need to pass user or application context. Some information that we know here at the front door should be passed to the backend. So this can be done in many ways. We receive application and user context maybe through the HTTP context, an HTTP header and HTTP body that contains the information. An API key or a client certificate can tell us who is the API consumer, or we can extract the information from the OAuth claims. And we can pass that information through the HTTP context, for example, in the HTTP body, or through OAuth claims to the backend API. So in this demo, what will we do? We will call the logic app, which does the actual connectivity to the backend system, and we will pass the email. So we will extract the email from the claim in API management and pass it in the HTTP body to logic apps. So back to the drawing board here, we have a logic app configured. Let me show it first to you. It should be over here. It's a logic app standard, so the latest release of logic apps. You have a get employee request response like this. Let me copy this URL. Yeah, and let me just send the email. Need to provide the email in a JSON body, and then I get back the response of that user. If I provide another email like this, we get the user back with a salary that exceeds the capacity. So you see, this logic apps is working pretty simple. Now I want to call this logic app from within API management. How can we do this? Let's go back to API management. And I want to do this through the backends functionality. This is something that already exists for ages in API management, but it was never visible in the portal. Nowadays, it recently became visible in the portal, so I want to show you that you can use that. Here you can configure a backend API, so you can reuse it in different APIs without repeating the same configuration. So you can configure it with a runtime URL, so it has a URL, and then some authorization credentials. And here in the query string, you can see the typical SaaS token that we use to connect to logic apps. The API version, the SP, and then the signature. Yeah. So thanks to this, we will refer in our policy to this backend ID, yeah, and API management will then automatically forward it to the configuration that is configured over here, and this will be our logic app with this complex query string. So enough talking, let's do that. We go to the HR API, we change here the operation policy, zoom out a little bit like this, and let me change the mocking, because I had mocking configured over here, and let's change it with this policy. It's a little bit more complex, but let me guide it through you. We do a get in API management, but we need to do a post to the logic app, so we change the method HTTP methods to post. Then the next thing is we route to the logic app's backend. We don't need to provide the URL and the query string. No, that's already configured in the backend, so we only need to provide here the backend ID. We want to invoke the logic app get employee info. We need to do a rewrite URI on the /invoke, and we can add the content type application JSON. Then the most magical thing here is extracting the email from our authorization header. So from the job token, we extract the email. Normally this should be with the email claim, but in my case it's the preferred username because they are not linked to Office 365. I put the results, the email, into a variable, which I will be using in the very simple liquid template, where we set the body to just the same HTTP body that we need to send here to our logic app. So let's save this. All right. Let me call now my logic app. My logic app, but through the API manager. So my employee info. And we should see that we now get another user back. It's not the mocked user anymore. It's the user 04, the one that I used to log in. I can show you that when I log in with another user, for example, with my demo user. Yes. If I do this login, yes, proceed and use the token. You should see now here that this email will change from user 04 to demo user. So you see, we are passing the user context from the claims into the HTTP body towards the logic app, which then, of course, takes care of the extraction of the information from the database. So we covered the complete front door security. We also passed some user information to the backend API. Now we need to also foresee the backdoor security. You have the same options available like you had over here on the front door. It's important, most of these responsibilities rely on the backend API. If we do network security, there's not much that we can do on the Azure API management side. We need to make sure that the backend API is protected like that. Because we are dealing with a logic app in this case, and it's a logic app standard, we can use the brand new feature of private endpoints, also sometimes referred to as private link. Because your logic app is deployed on shared infrastructure, you cannot deploy it easily in your own virtual network, unless you will explicitly host it, but that's typically not what you want to do if you want to leverage platform as a service. So thanks to the private endpoint, you can make sure that your logic app is consumable from within a virtual network and not from the internet. So if you enable private endpoint, I will not be able to call the API, the logic app anymore. It will only be able to call it if you are in the virtual network or in a peered virtual network like that. Your logic app really gets a private IP address in your network, in your virtual network that you configure. Of course, in your network, you will need to have some DNS, some local DNS resolution that makes sure that the host name that you configured on your logic app gets redirected to this private endpoint. So this is a very nice security measure, a network security measure that makes sure that your PaaS services, your platform as a service technology is not open on the complete internet. No, it's only available from within your virtual network. And in my case, in my demo, I will show you the API manager is configured with virtual network integration. First, let's show what we want to do. I want to enable here the private link between my API manager and the logic app. Let's go to my logic app first. Over here, we have a networking tab. Yeah, I really like the preview networking tab, where you have a visual representation of all the access restrictions and integrations that you can configure. What we want to do is private endpoints. So let me click on this one and add a new private endpoint. So this can be, for example, employee info endpoints. I need to specify the virtual network that I want to integrate with. Select the subnet. The API management subnet is a subnet where my API management is integrated with. So I take the other one, the backend API. And I ask here, I ask Azure to do the private DNS configuration for me. So it will create for me a private DNS zone that redirects the host name of the logic app to the private IP address that will be created for the private endpoint. While this is running, this can sometimes take a while, so I keep this running over here. I can show you that also my API management has network integration. So if you go here to the virtual network, you will see that it is exposed as in an external mode. That means that the backdoor of the API manager is inside this virtual network, and more specifically in this dedicated subnet. The outside is available on public internet. So that's why I could consume my APIs from my local machine. If you don't want your APIs to be available on public internet, you need to switch to internal mode. Be sure it takes approximately 45 minutes to apply such a change. So don't do it on the fly or during a demo like this. In the meantime, my private endpoint is added. If I click a refresh over here, it should be available. Yes. Let me now try to call the logic app directly, so without API management. And I hope that this will not work anymore, and that's good news. I'm not allowed to call the logic app from public internet. If I now want to do the same thing, but through my front door that goes through the API manager, which is in the same network as the logic app, it should work, hopefully. Fingers crossed. And yes, this works. So now we have the network integration also configured between our API management and our backend API. Last thing we need to think about is authentication. Also there you have the same options like on the front door side. We as an API manager, we can of course inject an API key. We can initiate the TLS mutual authentication. So the client certificate in the TLS handshake. But of course, it's a responsibility of the backend API to act upon it and to really enforce the authentication or even the authorization. In this case, I have already the network security, so I will just stick to the default logic app security with the shared access signature inside the query string. In many cases, you need to store those shared access signatures or the API keys in API management. And since recently, you can do that with Azure Key Vault. So you can create a named value, which is an app setting, an application setting, which you typically use for values that change per environment. You can now point that named value to a key vault where your secret is stored successfully and secretly. And API management will once a day fetch your value and will cache it internally. The same you can do for client certificates, but this is of course a very nice addition to make our API management solutions even more secure. So let me show you how we can do that. Remember that my shared access signature was configured on my backend. We had here the authorization credentials, the query parameter, and we have here this query parameter. I have already a key vault configured over here that contains that query parameter. That signature, the value of the signature, to be 100% clear. So instead of here using a manual value, I will create a named value. User experience is not that perfect, so let me try it like this. Yeah, I can create a new one. SaaS signature like this. And the value, I just do something like XXX because here I can only provide a value. I don't have the option to really link to key vault. But at least through this way, we will ensure that the named value is created, hopefully. Let's give it a little bit more time. Yes. Now I can hopefully select that named value. So is it now already secured? No, we have now a secret value inside our named value. But now I want to update my named value over here and point it to Key Vault. So I can click on it, change the type from secret to Key Vault, and I can point to my Key Vault instance. That should be here, this one, and I can select my secret that I showed you a little bit earlier. We use managed identity. So the managed identity of our API management has access rights on this Key Vault. I should double check this, but normally we should have here the Key Vault secret user, and this is our API management instance, is the Key Vault secret user, so it can read and use secrets. So if we click on save over here, our named value is now pointing to a Key Vault reference. Probably I need to do a refresh, and then you see that it has been successfully fetched. Remark here that you can explicitly fetch the secrets like this in order to make sure that the internal cache of API management is refreshed. So that's what we've done in the latest step of the demo. Apologies, I didn't show it before, but we stored our access key, our shared signature, securely in API management. So that's also integrated the good way. So this is a final overview of security and API management, and it's important for every situation that you need to check the boxes. Depending on the capabilities and the characteristics of your API consumers and backend API, you need to make the right choice. Typically, it's not only network security, it's not only authentication, it's often a mix of both security measures, because then you have a multi-layer security. If one of the layers would fail for some reason, you still have the other one. One more thing, just allow me to do a shameless plug over here. I have a very interesting training coming up with your Azure coach. It's about the new Logic Apps runtime. It's on June 25. So if you're interested, head over to your Azure coach and register for this unique training. Thanks a lot for the session. I will now have a look at the questions that might be in the Q&A section, and I'll go through them one by one.
I have accepted few questions, and it is there in the accepted tab.
All right. So the first question I get here, do we need an application gateway to implement WAF? No, you can use application gateway, but that's a regional service, and that's always also in combination with a virtual network. You can also use a front door. It uses the same WAF under the hood. It's sharing the same WAF functionality. Azure application gateway or front door, they use the same one. How does front door differ from application gateway? Good question. So application gateway is a local service. Azure front door is a global service. Azure front door also wants your API endpoints to be available on public internet, while application gateway only works at the border of a virtual network. So the backend side is inside your virtual network, and the front door is on public internet. I think that's the main difference. Of course, Azure front door is a lot more than only a web application firewall. It does load balancing, it does content delivery network, it does the load balancing and also the response caching. Yeah. Can you use TLS for security between front door and API management? Good question. I don't think you can start a new TLS handshake with a client certificate. It's not supported. What is supported or coming very soon is that Azure front door can do the certificate validation instead of API management. Because if you have front door in front of your API manager, your TLS will be terminated and reinitiated again. So if you want to do client certificate validation, it's not possible in API management because it was already terminated in Azure front door. I think we might expect that feature soon, or it is already available. I know it is somewhere in the works. It's one of the top asks for Azure front door. Is the access token specific to the API or to the specific to the user? It is specific to the API, to the application, and the user logged into that application. So the application, at least in my scenario, it always needs to access my API on behalf of a user. So it is specific to those three. It's specific for the user, the API, and also the application. How do you create app registrations in a corporate AAD if you are a simple client app or API dev? Yeah, one of the big issues indeed. Azure AD app registrations. It's a horrible experience. It's not user friendly at all. We also have, of course, no access rights to do so. You can get access rights if you are an application administrator, but not many organizations allow that. So in many cases, we end up, having a call with somebody who has elevated permissions, and then we need to say, please click there, please click there. And as a consequence, they often type the client ID and client secret just in a Teams window. So there's also no security. What you could do, and I wrote a blog about it, so you can go to yourazurecoach.com and look the blog, but you can automate that process. You can automate the creation of app registrations, and for example, make sure that the client ID and client secret that were generated, that you immediately put them into a key vault. In that way, you have a secure setup, and you don't need to communicate your client IDs and client secrets via email, via Teams, or via any other medium, because that's really the weak point of client ID and client secrets. It's the way people treat those secrets. So I'm a big fan of automating that process within the organization, but I know it's a real pain in the bigger enterprises to deal with that. How would you configure this using the client credential flow? So the client credential flow is more specifically for machine-to-machine communication. So my Postman would be a little bit more simple, of course, because that one should just do a call to the token endpoint with the client ID and client secret, and it would get an access token back. The way API management will be configured is also exactly the same, but we will not need to validate that scope over there because there is no scope involved because there's no user interaction. So the pure machine-machine communication, the client credential flow, is probably the most simple one to configure. Another question, how do you configure API management as an OAuth client, which retrieves the token by itself? Yeah, indeed. So API management can also act as the client indeed to request an access token and to call the backend API. So that's not so user-friendly to do in API management. You need to use the send request policy, which allows you to send a request to the token endpoint. Then you get the token back, and then you need to do some additional magic to make it happen. What you also could do in API management is use the on behalf of flow, where you can send your token, the incoming access token to API management, to Azure AD, and you get an updated token back that can be sent to the backend. So the experience, the developer experience is not that good because you need to do an explicit request to the token endpoint. Preferably, you add also some caching on top of it, so you don't go to the token endpoint for every request you get. It is possible, but it's not that simple. My advice is to head over to the GitHub page that contains a lot of snippets and samples of Azure policies, Azure API management policies, and you will definitely find there a way to use the send request policy expression to call to a token endpoints. Why do we need front door? Cannot we arrange odd stuff in API management? Absolutely. In my case, front door is not doing anything about the authorization. The only thing my front door is doing in this case is load balancing if I would have multiple regions, and it's doing the WAF, the web application firewall, to make sure that we are protected against the OWASP top 10 vulnerabilities. The OAuth, all that stuff is done in API management. So it might be that your solution doesn't need a WAF in front of it, then you can expose API management directly. It's just a matter, security is just a matter of risk mitigation. You need to make the trade-off for your situation. Does private endpoints for logic apps work for standard single tenant logic apps? Yes, and it's only there that it works. So if you use the consumption logic apps, the ones that we already know for years, there you don't have that network integration feature. So that's one of the main reasons why Logic Apps invested that much time in building building on top of the app service and Azure Functions runtime, because they can of course leverage now all these goodies, and VNet integration, private endpoints are very important, of course, because if you run in an enterprise context, you always need that network connectivity and network integration. Next question, can you configure a private endpoint for Logic Apps on a consumption plan? I think that was answered already. Unfortunately, no. With a consumption plan, you always need to connect or through the on-premises data gateway, or you need to expose your API on-premises in a public manner, so on public internet. You might also use Azure Relay. That's also an option that you can use. It's a hidden gem in Azure, but very valuable. Then I see the last question over here. Does the support for subnet's private endpoint require API Management Premium? Yes, yeah. So hosting API management inside a virtual network is only available in the premium or the developer tier. Of course, the developer tier cannot be used for production stuff. So indeed, it's rather expensive because we are at 2,500 euros, I guess, per month for an API management. I feel your pain. I have the same complaints. I agree it should be available maybe in the standard tier. We had already quite some discussions with it, but unfortunately, I don't see any change coming up pretty soon. But I agree, security is sometimes only available, the big security is only available in the premium or the higher tiers, and that's often a pity because security should be there for all of us. So I think I went through all the questions. So thanks a lot for the questions. If there are any questions after the section, you can always reach out to me on Twitter or through LinkedIn. And for the rest, I enjoy the rest of the conference. Don't hesitate to reach out, and see you later. Bye bye.
Covey.co